Wei-Meng Lee lives in Singapore, so it's maybe you already heard it's 11 at his place right now. If he falls asleep, then just shout loud to wake him up. Not so far from here. So Wei-Meng loves to read and never get sick of writing books. Most recent book is on Swift UI. Also loves to travel with family and have visited really many countries. I had list, but since Wei-Meng said that it's not complete, then it's long list of many countries. And Wei-Meng used to play a lot of badminton, but due to work had not played for some time, but still a huge fan of badminton. So if you like badminton and you are in Singapore, then you can always play with Wei-Meng, right?
Correct.
Yeah. Okay, that's it from me, and you're welcome to start.
Okay. Okay, thank you very much, Agus. So a very good evening to everybody. So my name is Wei-Meng. Like Agus mentioned, I'm based in Singapore. So I'm super excited to be here tonight to talk to you about one very interesting topic, and that is data analytics using Python. Now, I'm not too sure how many of you are actually Python developers, but not to worry. This talk is not about Python. So it's really about using the various tools and libraries in Python to do data analytics. So if you are a Python developer and then you are new to data analytics, then this session is good for you. But if you have not started on Python programming, then hopefully this session would motivate you to actually want to learn Python and then explore all the various libraries that are available to you for data analytics. And I think we are in a very good situation now where we have a lot of data. And for this particular talk, I want to focus on how to use the various libraries to perform some data analytics on the COVID-19 dataset. So some of you may already be very familiar that there is a lot of data sets floating around on sites like Kaggle, where you can actually download the COVID-19 dataset. And this is exactly what we'll do this evening. So we'll go through the dataset, and then I'll show you how to actually do some interesting analytics. So we will analyze the dataset, and then we will do some data visualization. So we'll plot some nice charts so we can see which are the countries that are flattening the curve. So let's get started. So for tonight's agenda, first of all, I'm going to give you an introduction to data analytics. What are the components, what are the steps involved with data analytics? And then we'll move on to Python, and I will give you a very short introduction to the various scientific libraries in Python. So in particular, we will talk about this library called NumPy, numerical Python. We will talk about this library called Pandas. I will explain to you what are the users of all these libraries. As well as this very important library called Matplotlib, which allows you to plot charts, 2D, 3D, professional looking charts using Python. And once that is done, we will go into the COVID-19 dataset, and then we will hopefully we will do some live coding, and then I'll show you how things work. So in the next 45 minutes, probably I will spend about 15 minutes just going through some of the basics of NumPy, Pandas, and Matplotlib, and then we will leave the next 30 minutes to analyze the COVID-19 dataset. Okay, so let's continue. So what is data analytics? So data analytics is the science of examining raw data to draw conclusions about that information. So today we collect a lot of data. And the problem that most companies face is, with all this data, what can we do with all this data? Can we get some intelligence from all this data that we have? And that is exactly the science of data analytics. Now, so what are the various steps involved in data analytics? So here is the sequence, the typical sequence that you need to go through when you perform data analytics. First of all is you get the data. And like I mentioned, most companies have got too much data. Now, once you got the data, what do you need to do with it? You need to clean the data. All right, you need to clean the data. Now, interestingly, for data scientists, in fact, they spend a good portion of the time in this whole data analytics process. They spend the majority of the time cleaning data. Okay, because normally the data that you have is raw data, and you have to do a lot of perform a lot of steps to clean the data. And once you have cleaned the data, you have to wrangle the data so that it can fit into whatever algorithms that you're going to use. Okay, and a lot of time is spent on trying to format the data to suit whatever you're trying to do. And once you have wrangled the data, you want to be able to analyze the data. And so that's where you use all the various libraries in Python to actually extract information. Now, extracting information is one thing. How do you actually present all this newfound knowledge about your data in a end user consumable format? And this is where you have to visualize the data. And like I mentioned earlier, you can use this matplotlib library to actually visualize your data to plot 2D, 3D charts. Now, so these are the steps for data analytics. Of course, you can go beyond this data analytics process. You can go and with the data that you have obtained, you can actually do machine learning, where you can actually do some predictions, or you can actually go one step further and you go into deep learning. So these two topics are, again, very interesting, but not really the scope of today's session. So for today's session, we will talk about more on data analytics. Now, we live in a data world. Okay, we have a lot of data. And there is this saying that says that data is the new oil. But then again, I think this statement is not really true. Why? Because the price of oil has actually went down quite a bit in the last couple of weeks. So no longer true that to say that data is the new oil, but you get a point. Now, let me share with you some interesting quotations. So without data, you're just another person with an opinion. So we are all presented with a lot of data. Okay, so but you need to actually get information out of all this data. So I like this quotation very much, which says that without data, you're just another person with an opinion. And there is one more very interesting slide quotation, which says that statistics are like bikinis. What they reveal is suggestive, but what they conceal is vital. Okay, so something for food for thought. Okay, so let's go into Python for data analytics. Now, why use Python? I think that's the first and foremost question that people ask. So Python is one of the most widely used programming languages in the world. So according to one survey result from Stack Overflow, it has overtaken JavaScript as one of the most questioned language in recent years. So, and for many schools, Python is being taught as a beginning programming language, and a lot of schools are doing that. And why? Because its syntax is really clear, and it is easy to understand, and it forces code indentation, and by doing that, your code becomes much more readable. And last but not least, there is an active communities of libraries and modules developers. So basically, whatever things you need to do, there are libraries that are able to do just that. And you don't have to reinvent the wheels, and you just need to install the libraries, and then everything will be done for you. So that's one of the good reasons why you need to start Python today, start learning Python today. Now, what are the tools that you need to install to use Python? Of course, there are many distributions of Python at this moment. You can install just the Python interpreter itself, but my favorite tool is still Anaconda. So what is Anaconda? So Anaconda is basically a package that contains all the various components that you need to do your work in Python. So it includes the Python interpreter, it includes all the various third-party modules, and it also includes an IDE, a web-based IDE known as Jupyter Notebook. So later on in my demos, I'll be showing you how to use Jupyter Notebook to actually build your data analytics process. So it supports Windows, it supports Linux, as well as Mac OS, and it, like I mentioned, it ships with Jupyter Notebook, and it makes your life really easy. Now, let's talk a little bit about Python. Like I promised, this is not a Python talk, but I just want to talk about something that's important in Python that makes data analytics possible. Now, Python has got this concept known as a list. Now, a list is very similar to arrays in other languages like Java, C#, Swift, Objective-C, so on and so forth. So it is a sequence of values. But the interesting thing about Python list, and the main difference between a Python list and an array is that in a Python list, all the items need not be of the same type. And here is one example of a Python list. So I have a variable called list equal to a collection of elements. So I have 4, I have a hello, I have a 3.14, I have a true. So in Python, a list can have different data types. So they need not be of the uniform data type. And so this is one example. And in Python, there's this concept known as slicing. So slicing allows you to obtain a range of values. So here's one example. So I have a list of items and I want to obtain the first 2 items. So I can do slicing using this particular syntax. I specify the list, specify the brackets, and then I specify 0:2. So it means that I want to obtain the first 2 elements of the list and I want to slice it up. So now, slicing is a big topic in Python, but just enough to let you know that you use slicing in Python to actually extract a part of your data. And this is very important for data analytics because very often you are presented with a big set of data and you want to be able to have the flexibility to extract certain rows, certain columns from a list. And this is what makes things possible in Python. Now, but there is one problem with Python list. In Python, a list, because it has got this flexibility, it allows you to store items of varying types. It is flexible, but for this flexibility, you pay with performance. The price that you pay is performance. So because of the way the Python list is implemented, accessing items in a large list is computationally expensive. And because of that, you need to have a third-party library known as NumPy, numerical Python. So what is NumPy? NumPy is an extension to the Python programming language, which allows you to have multi-dimensional arrays. So unlike list in Python, NumPy arrays need to have all the items to be of the same type. Because if you think about it, in real life data analytics, most of your data that you are dealing with, so either it's a row of data or if it's a column of data, they are all of the same type. So NumPy makes it very efficient to manipulate large amount of data of uniform type. So here's one example. So I have a list in Python and I can convert this list into a NumPy array using the np.array function. And once I have converted that into a NumPy array, I can do something that I'm very familiar in Python, and that is slicing. And I will be able to slice from my 1-dimensional, 2-dimensional, or 3-dimensional arrays. So arrays in NumPy are of this type called ND array, and it represents a multi-dimensional homogeneous array of fixed size items. Okay, so in summary, NumPy arrays are much more efficient than Python's list. Now, NumPy has got this very, very powerful concept known as Boolean array indexing. So let's consider one example. So I have an array of numbers, 25, 45, 78, so on and so forth. And let's say I want to retrieve all the even numbers in the array. Now, using conventional programming languages, what would you do? You would basically write a loop to loop through all the items in the list and then pull out all the numbers that are even. Now, using NumPy and using this concept known as Boolean array indexing, you could do the following. Let me just show you the one in yellow. You could simply do nums, specify a bracket, nums modulo 2 equal 0, and it would return you all the even numbers in that array. Now, if you want to extract all the numbers that are greater than 5, you simply do a nums greater than 5, and it would automatically returns you all the numbers that are greater than 5. Okay, so that is NumPy arrays. Now, the next library that you want to talk about when you want to do data analytics is Pandas. Now, what is Pandas? Pandas stands for Panel Data Analysis. It is basically a library that allows you to manipulate data, your data, that is stored in a table format. Most of the time, when we talk about data analytics, where is the source of your data? Most likely, it is stored in your CSV files, or you may be retrieving from a database where you have a table of rows and columns. So Pandas is a library that allows you to represent your tabular data in memory so that you can actually do and perform all your necessary analytics. So here is one example of a data frame. So I am trying to create a data frame of 10 rows and 4 columns. And using slicing, I can actually extract specific rows that I want, specific columns that I want, as well as specific rows and columns that I want. Okay, so that is the idea behind data frame. It's basically a data structure for you to represent your data in tabular format. Now, bear with me for a while. The last library that we want to talk about is data visualization. Now, in data analytics, a picture is worth 1,000 words. So you may perform a lot of analysis, but then ultimately you want to be able to present them in a easy to digest manner. So what's the best way to present a set of data? I think a picture is the best way to represent whatever you have analyzed. So in Python, we can make use of this library known as matplotlib. So matplotlib is a Python 2D, in fact, it's 2D, 3D plotting library which produces publication quality figures. And libraries like NumPy and Pandas, they have inherent support for matplotlib. So you can plot directly from your NumPy array or your Pandas data frame. So here is one simple example where you could actually plot a very simple line chart with just a couple of lines of code. Okay, so that is matplotlib. Okay, so we have finished the foundation. So I think this is something that is very interesting, and then we want to talk about this COVID-19 dataset using Python and what are the things that we can derive out of this. So now this is the dataset I'm using. I'm using this dataset from this website called Kaggle. So now this dataset has got a lot of files, and I'm going to now exit my Keynote, and I'm going to show you the dataset that I have downloaded. Now, this is the dataset that I have shown you. So basically, when you download the dataset, so I'm not too sure whether you can see this very clearly or not, but not to worry. I'll try to run through this. You just get the main idea. So when you download this dataset, it has got a number of CSV files. Okay, so in particular, we are going to make use of these 3 files: time series COVID-19 confirmed CSV, time series COVID-19 recovered, and deaths. Now, the first CSV file lists all the confirmed cases for all the countries in the world. So if I were to show you this, this is the confirmed data set. Now it shows you countries like Afghanistan, Albania, Algeria, so on and so forth. It also shows you the province or states for each country. And it even shows you the latitude and longitude for each country, as well as the dates recorded. So for example, in this particular column, it shows you that on the January 22nd, there is 0 confirmed case for Afghanistan. And then on the next column, it shows you the date for January 23rd. And so you can see that all the dates are represented as columns. Okay, now same goes for the data set that is, let me just quickly show you, confirm. Let me just pull out my data set. Okay, and then the dev data set. Same goes for the dev data set. It basically shows you the number of devs for each country with the dates represented as columns. Now, when we perform data analytics, we always have to do some data wrangling, like I mentioned. So we do not like this particular format because as the day goes by, you have additional columns. So we want to be able to actually convert all those columns into rows. Okay, so we need to unpivot the data. So let's run through the steps on how we can actually make use of this data set. So now the first thing that we want to do is that we want to import the relevant libraries in Python. So we want to import the NumPy library. We want to import the Pandas library. So let's run it and then let's continue. Now, we want to be able to load the CSV files. So let's load it up. And once we have loaded up the data files, we want to print out the shape. So as you can see here, the first data frame represents the confirmed data set. It has got 266 rows and 129 columns. Okay, same goes for the dev data set. 266 rows and 129 columns. But interestingly, for the recovered data set, it has got 253 rows, but 129 columns. Why is that so? The reason is because, frustratingly, if you look at the recovered data set, and if you compare that with the confirmed, let's take a look at this. For the recovered data set, they store, let me just Canada. And then for the confirmed case, let's take a look at this. Okay. Now in the confirmed data set, it stores the various states in Canada. So you have different rows from the different states in Canada. But unfortunately, in the recovered data set, they only lump everything into a single row for Canada. And because of that, when it prints out the shape of all the data frames, you get different numbers. So this is something that you have to be careful. So for this reason, and to keep things simple for our this mini project, we're going to ignore this recovered data frame. So let's not use that recovered data frame. Now, so what are we going to do? We are now going to load them up and we're going to sort them. And we want to take a look. So this is my confirmed data set. My confirmed data set is here. So I have the province, the country, the latitude, longitude, and the various dates. And followed by, so each row represents each state in the country, so on and so forth. So we are also going to load up the dev dataset. And I have all these rows. Now, the next thing that I want to do is this. I want to print out the dates of each column here. So in this case, I want to print out the dates for the recovered, for the confirm and for the dev data set. I want to print out the dates to make sure that all the dates are the same for the two CSV files. So let's do this. So it prints out that, hey, for the confirmed dataset, let's not worry about the recovered. For the confirmed dataset, the date starts from January 22nd, ends on 25th May. Likewise, for the dev dataset, it starts on the same date, ends on the same date, and I want to programmatically check whether these two data frames has got the same dates. Okay, so they are the same. And so when they are the same, I can now go ahead and unpivot them. Now, what am I trying to do here? Let me show you. So I'm trying to unpivot the data frame so that now the data frame looks like this. Oops. Let me run this first and run this. So that now I do not have each column for each date. So instead of each column for each date, I unpivot the date column into rows. So now I have a new column called date with all the various dates compressed. So I have all the first 200 over rows, which is January 22nd, and then another 200 over rows for January 23rd, so on and so forth. So likewise, I'm going to show you the dev dataset. So the earlier one shows you the dataset, or rather the data frame for all the confirmed cases. And the next one shows you the data frame for all the dev cases for each country. And let's print out the shape of each one. So now the confirmed data frame has got 33,250 rows and 6 columns. So, and the dev data frame is also the same thing. And so let's now combine these two data frames into a single data frame so that I have a data frame containing all the states, province, country, as well as the latitude, longitude. And then I have a column that says all the confirmed cases, and I have a column that says all the dev cases. So let me just put in my code here. So now I have a nice little data frame that combines the confirmed cases as well as the dev cases. Okay. Now, and usually, sometimes if your data set has got empty values, it is important to fill the empty values with zeros. But in this case, I think there isn't any empty value, so we are pretty safe. So what's the next thing that we need to do? Now, we are going to print out the data types for each column in your data frame. So we can see that the province column is an object, which is a string. Same goes for country region, which is a string as well. And for the latitude and longitude, they are both floating point numbers. And the date is an object. Now, in this case, the date is an object, which means that it is a string. And when this is a string, when it comes to sorting, you are going to have a lot of problems. So in this case, we need to convert this into a datetime format. So we're going to convert the date column into a datetime format. So let's convert this. So now my date, instead of 1/2220, it has been converted into a date format. Okay, so that internally Python can do date sorting later on. Now, once this is done, we can perform some simple analytics. So we want to know what are the daily numbers for confirm and def cases. So I can group the data frame. I can group the data frame using the date column. So I can do a data frame combine group by date. And I can iterate through this particular group by object and print out the numbers for each day. So I'm going to run this and you're going to see the value. So it says that on January 22nd, you have the following cases. So I'm going to reduce the size of this so that you can see this very clearly. And then on the January 23rd, you have all these values. And then January 24th, you have all these values right up to the last day, the most recent day. So for my data set, the most recent day is the May 25th. And so these are the values. Now, so I can also want to know that, okay, so in this case, it has got the data for the various states and province for each country. What about, can you summarize all the cases for each country? And let's not subdivide into provinces and states. So I can do something like this. So I can apply a aggregate function. I can sum up all the confirm columns and all the def column based on the date and based on the country and region. So when I do that, now I can get a total of the numbers for each day and for each country. So in this case, I see that now I'm not seeing the full column, full rows, because by default, Pandas restrict the maximum number of rows to print to be 10 rows. Okay, of course you can override this, but for now this is fine. So I am seeing the numbers, and I'm also seeing the numbers for the last day. Okay. Now, what happens if I want to get the data for a specific day? I can specify, okay, which day do I want? I want to extract the value for March 22nd. So I can run this, and it will print out that for this particular day, these are the numbers. Now, if you're interested in today's, or the last day is May 25th, and these are the values. And you can see that places like Afghanistan, the numbers are pretty high. Okay, now I can also get the data for a specific day for a specific country if I want to. So I can specify on this day, May 22nd, for the US, the number of confirmed cases is this, and the number of deaths is this. And let's say I want to know what is the situation in Latvia. I can just type in Latvia and then I run. And on this particular day, the number of cases, confirmed cases, is 1,000, and the death is 22. Okay, now, so what happens if I want to know what is the data for the most recent day? So I want to be able to programmatically find out what is the latest date that I have. I can extract the latest date. And then based on this latest date, I can actually print out the numbers. So this is basically the same as what we have entered manually earlier on. Okay. Now, and what happens if you want to know which are the top 10 countries with confirmed cases? So I can do that as well. I can sort the data frame by the confirmed column and then print out the top 10 rows. So in this case, you can see that the US has got the most number of confirmed cases, followed by Brazil, followed by Russia, followed by United Kingdom, so on and so forth. Okay, now, so again, we can actually write some simple code here to ask the user to enter the country that they want to know. So enter the country. So for example, if I type, I want to know the cases for Singapore, and you'll see that for Singapore, for the most recent date, 25th of May, we have 31,000 cases, which is a lot. And we have 23 deaths. Okay, and then I can try this with another country, US, and I get all these values. Now, I can also find out which are the countries, top 10 countries with the most deaths reported. So again, I can sort the columns by the data frame by the deaths column. And again, you can see that US is #1 in terms of the number of deaths reported. And what happens if you want to dive deep into a specific country, let's say China, and you want to know which are the provinces? Okay, the data for the various provinces. So I can go into the combined data frame, specify the country that I want to retrieve, and I want to group them based on date, province, or state. And then I want to perform an aggregate based on the confirm columns as well as the death column. And so based on this data set, you can see that these are all the various provinces in China with the confirmed numbers and the death numbers. And you can see that Hubei, which is the capital city of Wuhan, has got the highest number. Okay. And instead of sorting it manually, we can actually write the code to print out the top values, and we can sort them in descending order. So you can see that in this particular chart here, Hubei is #1, followed by Guangdong, Henan, so on and so forth. Okay. Now, so far, these are all the numbers that you can extract from this data set, a lot of interesting numbers. So what happens if instead of looking at all these tables, all these results, we want to be able to perform some visualization. We want to plot some charts. We can do that. So in the next example, I'm going to show you how to actually plot some bar charts. So I'm going to make use of this library called Matplotlib. And we are going to plot the charts for each country. Okay, so I'm going to run this. It's going to take a bit of time. And there you go. So you can see that for Afghanistan, the light blue bars represents the confirmed number of cases, and the red bar represents the number of deaths for each day. Now, notice that all these numbers are cumulative. That means the numbers represents the accumulated figure from the previous day. So every day it adds up to the previous day's number, and then it is cumulative. So you can see this. So this is Afghanistan, and then you can see all the various countries, how the various countries are performing. Let me see, Australia, Austria. So maybe let me just interrupt this, and then so for each country, okay, so if country equal Latvia, let's print out just for Latvia. So let's run it. So you can see that this is the chart for Latvia. Okay. And what about Singapore? So Singapore is something like this. So you can see that there is a steep climb on this particular date. Okay, so using this, you can actually see the performance of each country, whether they are accelerating or not. So now I can also print out the top 10 confirmed countries as a pie chart. So let's do this. So I have a function here that says plot pie. And so let me just run this. And let's plot the top 10 countries. There you go. And you can see that US is number 1, followed by Brazil, followed by Russia. So it goes, you can look at this in an anti-clockwise manner. From here all the way to India is in the number 10 position. And if you want to know the top 10 provinces in China with the confirmed cases, then we can simply call this plot pie function with this particular data frame. And then we get this value. Okay. Now, something interesting. What about dev? So before we talk about that, so let's talk about the top 10 countries with dev reported. So in terms of number of devs, US is number 1, followed by United Kingdom, followed by Italy, France, Spain, Brazil, so on and so forth. Okay. Now, something interesting about the curve that we have seen here, the charts that we have seen here. Now, if you recall, I mentioned that the numbers are all cumulative. They are all cumulative, which means that all the numbers are added to the numbers reported yesterday. Now, you always hear this phrase, flattening the curve. So in this example, how do you know whether the situation is improving? Okay, it is very difficult to see this just from this chart because almost all the charts, the numbers are always, in fact, all the charts, the numbers are increasing. So it is very difficult for you to actually know whether a particular country is flattening the curve. So in this case, what do we need to do? We need to unroll the cumulative figures. So instead of using the numbers that are cumulative, we want to actually separate the numbers so that we want to have the numbers for each individual day. We want to know on this particular day how many unique cases are there. Likewise for the subsequent days. So here is what I have done. So I want to plot for each country, and the important thing here is that we are trying to unroll the values. We are trying to do a reverse cumulative sum so that the numbers can be reported for each day. And let's take a look at this. And so in this case, you can see that for countries like Albania, it is doing, well, not too bad. It initially was going up and then now it's slowly coming down. So again, let me just interrupt this. And instead of looking at all the countries, let's do this. If country equal to Latvia. So let's try this out. Okay, so if you look at Latvia, it's doing pretty well. So you can see some spikes on this particular 1st of April, and then it's slowly coming down. And then if you look at the DEF here, DEF is pretty flat. And then you look at places like Singapore. So there was a huge spike on this particular day, and then it slowly is coming down. Okay, and the number of devs is relatively low. So you can see an almost flat line here. And what about US? So if you look at US, it's like US is not really flattening the curve yet. You can see that there is a huge spike here. And the curve, even though it seems like it's going down, but it's going down a little bit slowly. Okay. So this is what you can do with all the various data, and then you can actually perform a lot of very interesting analytics with that. Now, the last one that I want to talk about is we have all these cases. And we are able to plot all this using bar charts, using line chart, using pie charts. It would be really nice if we are able to take all these cases and plot it onto a map. So in fact, that's what we're going to do. Now in Python, there is a library, there's a module called Folium. So Folium is a Python library that helps you create several types of leaflet maps. And leaflet maps is basically based on OpenStreetMaps. So leaflet is basically a leading open source JavaScript library for mobile-friendly interactive maps. And it's really, really cool. So let's see how this can be done. Okay, so what I have here is that I have a block of code here, and I am basically making use of this Folium library that allows me to plot a map, and for each place, so here I'm plotting not just based on country, but also based on provinces and states. So I am taking the coordinates of each location and then plotting the number of confirmed cases as well as number of dev cases. And for each confirmed case, I will display a green circle. And for each dev, for each location, I will display a red circle. And the size, the radius of the circle, it's going to reflect the size of the numbers. That means if a particular place has got very high confirmed number of cases, the radius of the circle will be big. Likewise, if the specific location has got a very low number of devs, then you would have a small circle. So let's run this and see how it looks like. So I'm going to run this. So, and the output is going to be saved onto a HTML file called COVID-19 map.html. And I have already preloaded this here. So let me just reload this, refresh this. Okay, so this is the map that I have generated. So as you can see here, the United States has got the biggest circle because based on the numbers of confirmed cases, it has got it's ranked number 1. So you can see that it's really big. And the other places with all these red dots means that the number of confirmed cases are relatively small. So let's go in and see whether we can find Latvia. So Latvia is here. So Latvia is pretty good. So in terms of the size, it is still pretty small, compared to some of the neighboring countries. I think UK is pretty severe. And then where are some of other places? You have Belgium, and let's zoom out. India. India is pretty bad as well in terms of number of confirmed cases, but in terms of dev, it's still relatively small. Okay, so this is what we can do with Folium. Okay, now I know we have skimmed through a lot of details, but basically I wanted to give you a feel of the things that you can do with Python, as well with the various libraries, the scientific libraries in Python, namely NumPy, Pandas, Matplotlib, and then with the last section, the Folium on how to plot maps. Of course, you can use Google Maps if you want to. The choice is really yours. The downside about Google Maps is that you have to pay for the maps. It's no longer free, but for Folium, you can actually use a open source maps, which is pretty nice. Okay, so I think I'm done for this particular session. So if you have any question, you can feel free to let me know in the chat window. I'll try my best to answer them. If not, you can always send me an email, or you can I'll give you my email. If you need to contact me, you can. Okay.
You can type it in Q&A. I will so it will be visible also.
Sure.
It will be better visible and also visible after
sure.
After you finish.
Okay, so I think I will stop sharing my screen so that I can see the chat window. Okay, cool.
So yeah, and if anybody has questions, then so two options right now. You can ask in Q&A of in Microsoft Teams. Just be ready that it will take some 10-20 seconds while I approve it, and then we can see it. And or you can ask them in Slack, because Wei-Meng Lee is in Slack as well, right? In that club.
Yeah, I'm going to join the Slack pretty soon. So
you didn't? So here is link also in Q&A section. There is link. You can just click on it and you will be in.
Egas,
you don't see it?
It says that the link is no longer active. Are you able to double check on that?
Check. I think I updated it
right.
Just like, I don't know, it is tricking me. I'm not, it's kind of right, but why it doesn't work?
Okay, so you have one.
There is this equal symbol at the end. Maybe that's the reason. Does it work now?
Let me see. Okay.
Just reminding people, so if you have a question, you can ask them here. Okay, here's something written.
Okay.
I make it, I publish it. You should see it now, Wei-Meng.
Sure.
Have you used Power BI, and if yes, can you compare it with these Python libraries? What are benefits on with other?
That's an interesting question. To be honest, I've not used Power BI before, so I can't really compare that with this Python libraries. So unfortunately, I'm not able to answer that because I've not used that.
Okay, here are two more.
Okay.
Okay, here's comment.
Okay.
Somebody liked. And here is Mars' question.
Okay. Yeah, thank you.
Yeah, I also thought that you sit somewhere in a public library.
Okay.
So,
Mari's,
next question.
Mari's question is that what are the main advantages to use Python modules instead of Excel built-in function for data analysis? Okay, so I think that's a very good and valid question. So, of course, to different people, some people may say, hey, I can use R to do that. Some people can say I can do most of the things that you have mentioned using Excel. But if you are a developer and you want to do beyond just data analytics. For example, I want to be able to analyze the COVID-19 dataset, and at the same time, I want to be able to publish this as a REST API. I can do that very easily. So I can use the Flask library, and then I can package this as a REST API. And for example, my REST API allows people to actually send in a query. Okay, so show me the latest map for today. And I can update the map in the back end, and then the user can actually use a browser to actually check, okay, what is the latest number of confirmed cases in the world. So it all boils down to Python being a very flexible programming language, and it allows you to do anything beyond data analytics. I hope that I have answered that question. It's
okay,
flexible.
Yeah, and there is next one by Anonymous.
Okay.
I'm new, but how can I calculate this as percentage of confirmed cases? I assume this question is not about mathematics in general, but about how to do it in Python.
So the question is that how do you calculate the percentages? Is that the question?
I assume.
Oh yeah. So okay. So without going into the actual code itself, you can calculate percentages. Not a problem. In NumPy and in Pandas, you can basically perform calculations very easily. You can perform multiplications, divisions on arrays directly. You can also perform all these operations on columns in a data frame. So all these are possible. You can apply, like for example, we saw the examples on aggregate function, where we can say we want to sum up all the confirmed numbers for each day, for each country, or if you don't want to use the built-in aggregate functions, you can always write your own function, and then you can actually calculate the percentage of death with respect to confirmed cases. You can do just that.
Okay, here's next one by Anton about NumPy.
NumPy, okay. Let me see. Oh, okay. I think it's scrolling now. Okay.
I can read it. Just that
Sure.
Those who watch know what we talk about. NumPy is most common thing that I see related to such kind of tasks. Do you know similar things are on different languages, or maybe is there a reason why Python and NumPy?
Okay. So you mentioned that NumPy is the most common thing that you see related to such kind of task. In fact, I think for such kind of task, of course you can use NumPy to do all this, but I think for such tasks, I think Pandas would be a much more better candidate. So far, all my examples are built using Pandas. Do I see similar things on different languages? Let me see. So I think the closest features is R. I think R has got very similar functionalities. Okay, but like I said earlier, if you are purely doing data analytics, yes, I think R is a very good language to use. But if you are venturing beyond data analytics and you want to do other tasks, then Python is the next best candidate. Hopefully that answers that question. And of course, as a developer, the amount of questions asked on Stack Overflow, it's a good reason for you to start learning this language, because when you need help, there will be a ready pool of people who is able to answer your questions.
Okay, it seems that no more questions right now, so I suggest that we do it right now this way, that we kind of have break for 5 minutes.
Okay.
And if any new question will appear in these 5 minutes, then you answer.
Sure, sure.
And if not, that then at 7:20 it will be 6-minute break.
Okay.
7:20 Bogdan will start his talk.
Okay.
Hopefully he's still here. Maybe he falls asleep. No, sound is not sleepy sound. No. So how many languages, programming languages, do you know, Wei-Meng? How many you can really do programming?
I think let me see. So I think Python is the one that I use I think the most often for the past couple of years. I also do quite a fair bit of Swift because I develop iOS apps. I'm more recently I'm going into the Go programming language, Golang. I think Golang is a fantastic language for doing concurrency programming. I also in the past few years I've been using Dart because I do a lot of Flutter for cross-platform mobile development. And in the past I used to do a lot of C#, but probably not for the past few years. So for the past few years I'm more concerned about more into Python, Swift, Golang. In the past, I used to do Objective-C, which was really painful. It's not for human beings.
Objective-C?
It's really painful.
I will remind here link to feedback form for your talk.
Right. Okay.
No new questions at the moment, but
okay.
We have 4 more minutes for that.
Okay.
I heard sound in a background while you were talking. Is it what's the just human question, not programming? What's the normal time when you go to sleep at your home?
We tend to sleep late. The earliest that we sleep is about maybe 11:30. But so for the past, because we are in some sort of like lockdown, and
yeah.
and we don't need to wake up early in the morning to travel to work. So for the past few weeks we have been sleeping quite late, about 12:30, and my girl also sleeps very late. So
how old is your girl? She's something like 5?
6.
6, yeah.
Yeah. So and that's when you have the kid staying at home with you 24 hours a day, and sometimes they will drive you crazy.
Yeah, I have 2 of them. One is finishing grade 4, and daughter is finishing grade 3, and my wife is mostly dealing with them at school time, and yeah, we make crazy each other. Luckily, I live in a private house and we have yard, so we can go out. So it's easy for us.
Yeah, that's true. That's true. So, but sometimes they can really drive you crazy.
Oh, yeah. So what's your next programming language? Which do you plan to learn?
Okay, so I have been pretty busy with Golang lately. So Go is the language that I'm trying to focus a lot at this moment. So I don't know. There are always new things to learn. It's totally crazy. It's totally crazy. But I think Python is a language that is worthwhile learning. I'm not too sure how many of the audience here today are Python programmers. It'll be interesting to ask how many of you are actually Python programmers. I'm not too sure whether everybody is.
I don't know how to collect the answer, but at Latvia so far I have heard two answers. Like there's very little amount of people who do program Python, and they say that Python is cool, and then all other, it's like, I don't know, 95% of programmers, they say that they hate Python.
Oh, okay. Okay.
So okay. I don't know why exactly they hate it, but it's like very opposite. Either they love it or they hate it.
Okay. Yeah, probably because it's a little bit different from your conventional programming language where you have open brace and close brace to indicate a block of code. In Python, you don't use braces. In Python, you use indentation spaces to say that, okay, this is a block of code. So they don't use, it doesn't use open brace, close brace, and okay. That's maybe why people really hate it.
Could be, yeah. Okay, so no more new questions. Thank you very much for your talk and for connecting, and wish you good night.
Yeah, thank you. Have a good day.
Yeah, and it's evening for us as well. Yeah.
Yeah.
And hopefully we have you again in Devclub in future.
Okay, sure. Thank you.
Okay. Yeah. Thank you.
Thank you.